Okay, looking at example 1 on this tape 69 for rational expressions, what we're saying is we're going to add fractions. Okay, so let's review the concept of adding fractions. All right, so if I have 2/3 plus 5/3, I have 2/3 plus 5/3, then I say I have 7/3, don't I? Other words, when we add, we do not add denominators. When we have the same denominator, then we just add or subtract the numerators. So if you have the same denominator, you just add or subtract numerators. I'm going to say that 4 times. So that's the whole key to this entire tape. And that is, if I'm adding fractions and I have the same denominator, then all I do is write down that denominator and add or subtract numerators. So when adding fractions that have the same denominator, you add the numerators or subtract if that's a minus sign. And so the answer to this is 8 over x. Okay? When adding fractions, if you have the same denominator, you simply add or subtract numerators. All right, let's look at the second example. Now, example 2, here's what I want you to hear. If you have a binomial, two things here, added or subtracted, put them in parentheses. All right, now what we have is the same denominator. We have the same denominator. Therefore, the statement is, if we have the same denominator, we simply add the numerators over that common denominator. Now, you can leave parentheses here, which I think is a good idea. Now, as before, when you were adding fractions, you're supposed to reduce them when you get through. So what we have here is we have a common factor. So we'll factor out an A, and that leaves us that parenthesis. And down here, I have the same parenthesis. So it divides out, and our final answer is A. Here's another reason why to write these in parentheses. Here's what some students do. If they don't have that parenthesis there, they'll go in here and divide that A with that A, or that 3 with that 3. And you can't do that. Keep it in parentheses. The only way you can divide that out is if you can find another parenthesis just like it. All right, so let's look now at example 3. Now, example 3 is trying to show you be careful of minuses in front of parentheses. All right, what's our statement? Put binomials in parentheses. Okay, we have a common denominator, so we simply add or subtract the numerators. Okay, now remove parentheses. So we have x plus y. Minus times a plus x is a minus x, and a minus times a minus y is a plus y over 7. And look what happens. The x's add up to 0, and so what we have for a final answer is 2y over 7. Okay, so this example is trying to point out the idea of watching out, removing parentheses, and changing the signs. All right, let's go to example 4. In example 4 now, we don't have the same denominator. So what we do is we come over somewhere and figure this out. Whether you write it down or not, people use LCD, lowest common denominator. Well, what is the common denominator? Well, it's the common denominator of the numbers. Common denominator of 3 and 1 is 3, and it's the highest power of each individual letter, so it's y squared. Now, what we do is multiply the top and bottom by whatever it takes to get this common denominator. So I need to multiply this by 1, and so I multiply the top one by 1. Okay, here I need to multiply it by 3y. So multiply it by 3y. Don't forget, whatever you do to the denominator, in terms of multiplication or division, you must do the same thing to the numerator of a fraction. All right, now what we have is 14 over 3y squared minus 9y over 3y squared. And now we're back to the other example. We now have a common denominator, so we add or subtract the numerators. That's a binomial, put it in parentheses, so that you do not divide out these y's or 3's here. So that is a binomial, put parentheses around it. And you cannot get rid of that until you find another parenthesis just like it. But also don't forget to look for a common factor. Okay, and there is not any on this one, so there's our answer. Okay, so let me review it one more time. Example 4 is saying when we don't have the same denominator, then make it that way. Okay, so multiply the top and bottom by whatever it takes to make the same denominator. And it doesn't have to be the lowest common denominator, just as long as you multiply the top and bottom so the denominators are the same. Then you just add and subtract the numerators. Now if you don't pick the lowest common denominator, the final answer will always reduce. Sometimes it still does, even with the lowest common denominator. But if you don't use the lowest common denominator, your answer will always be able to be reduced. All right, let's go to the next example. Example 5. Okay, what's our first step? Parentheses. Put parentheses around every binomial. Now, what is the lowest common denominator? The lowest common denominator, let's do this. What's the lowest common denominator in 1/3 and 1/5? Well, it's 3 times 5. If those denominators are different, then it's just this times that. So, up here, our common denominator is, I'll go ahead and write it, is the parentheses x minus 3 and x plus 4. Therefore, what is missing here that's in the common denominator? What do I have to multiply this by to get this common denominator? Well, it's the x plus 4. Well, I must multiply the top by the same thing. Now over here in this fraction, I have the lowest common denominator. Over here, what is missing? Down here, what do I have to do to multiply the top and bottom? So now, let's rewrite this. Okay. So this is x squared plus 6x plus 8 over the common denominator. Don't multiply the denominators together. Okay, minus x squared minus 8x plus 15 over x plus 4, x minus 3. I have the same denominators, therefore it is x squared plus 6x plus 8 minus the parentheses. Okay, go ahead and put that in parentheses. If you don't, you're going to make a mistake in here in the sign. All right, over. All right, next step, remove parentheses. So what we have is x squared plus 6x plus 8 minus x squared plus 8x minus 15 all over our common denominator. Now simplify the top. X's squares drop out. We end up with 14x minus 7. Okay. 14x minus 7. Down here we have x minus 3 and x plus 4. Okay? And now, we look at the numerator. Go ahead and put it in parentheses. Common factor there is 7, so that leaves us 2x minus 1 over x minus 3, x plus 4. No parentheses are the same, so I can't divide anything out, so that's my answer. Now, that answer is sufficient as this answer. Back of the book, you might see it written this way. Okay? That's still the same. As long as it won't reduce, one of these parentheses won't divide out, then you don't have to factor it out. You can leave it like that. All right, let's go to the next example. Now, what this example is trying to do is to show you, if you have something like that, really what you have is 1 over 1. Because you have this parenthesis and 1. So your common denominator is x plus 4. So therefore, all I have to do is multiply this top and bottom by x plus 4 and x plus 4. So what I have now is a minus 2 over x plus 4 plus x plus 4 over x plus 4. I now have the same denominator, so I add numerators. So what I have on top is x plus 2 over x plus 4. Okay, now putting parentheses there, they're not the same, cannot reduce it, that's the final answer. Now again, leave it like that personally, okay? Your teacher may write it this way, or back of a book may write it this way. Same answer, but I like the idea of keeping parentheses around binomials so that you don't go in here and divide this 2 with that 4 and you won't mark out those x's. All right, let's look at the last example. All right, looking at example 7. Now, these other examples, it wouldn't be bad for you to go back and review the tape and watch them one more time to check things. Number 1 was if we have the same denominator, then we just add the numerators. Number 2 was if we have different denominators, then we must multiply the top and bottom, each fraction, so that we get the same denominator. Then we go back and add numerators. Then we looked at if you had a parenthesis with a minus, watch out for that. Okay. Then we looked at multiplying the top and bottom by these parentheses, binomials, to get to be the same. Now what this example has added to it is to factor. So if you can factor the numerator, do so. Well, we can't factor that one. But the bottom one we can factor into x plus 2 and x minus 2. And over here, we can factor a 3 out of this one. Okay, now don't forget to put parentheses around binomials. Now then, we look up here and we see what our common denominator is. Well, numbers, 1 and a 3, so our common denominator is 3, and then all the different parentheses. Now please listen, this problem doesn't have it, but if I have one of these parentheses to the squared power, then I have to have it squared down here. If I have one of these parentheses in the same denominator that raised to a power, then I have to have it that many times down here. All right, now that we have decided what the common denominator is, we need to multiply the top and bottom of that. So this one, we need to multiply by 3. So we multiply the top and bottom by 3. Okay, this one, we need to multiply by x plus 2. So now we have the same denominator. So now we write that down. And now we write down the top. 3 times 2x minus 3 plus x plus 2 times x plus 2. All right, so what do we have now? We have 3 times 2 is 6x. 3 times 3 is minus 9. And then this is 4 method, x squared. Last term is 4. Middle term is 4x. And that's a plus in front of that. So I don't have to put that in parentheses. If it's a plus, I just leave it like that. Over 3x minus 2, x plus 2. So what do I have down here now? X squared plus 10x minus 5 over 3 times x minus 2, x plus 2. Now, don't forget, always look to see if you can factor the numerator. Okay? We cannot factor the numerator, therefore that's the answer. Okay, I hope this kind of gives you the idea of all the different basic concepts you need to know. But the most important thing I'd like for you to remember is you do not add denominators. You get the same denominator and then you just add, subtract numerators. Okay, works several of the examples and maybe that'll help you.